Okay, today's problem. Your plane lands with plenty of time to spare. The final leg of your journey is a ferry that goes directly to the tropical island, where you can finally start your vacation. As you reach the waiting area to board the ferry, you realize you are so early, nobody else has even arrived yet. By modeling the process people use to choose or abandon their seat in the waiting area, you are pretty sure you can predict the best place to sit. You make a quick map of seat layout, your puzzle input. The seat layout fits neatly on a grid. Each position is either floor, dot, or empty space, empty seat L, or an occupied seat hash. For example, the initial seat layout might look like this. No occupied seats. Now you just need to model the people who will be arriving shortly. Fortunately, people are entirely predictable and always follow a simple set of rules. All decisions are based on the number of occupied seats adjacent to a given seat. One of the 8 positions immediately up, down, left, right, or diagonal. The following rules are applied to every seat simultaneously. If a seat is empty and there are no occupied seats adjacent to it, the seat becomes occupied. If a seat is occupied and 4 or more seats adjacent to it are also occupied, the seat becomes empty. Otherwise, the seat state doesn't change. Floor, it really reminds me of Cellular Automata and Game of Life. After one round of floor never changes. After one round of these rules, every seat in the example layout becomes occupied. After a second round, the seats with 4 or more occupied adjacent seats become empty again. This process continues for 3 more rounds. At this point, something interesting happens. The chaos stabilizes, and further applications of these rules cause no seats to change state. Once people stop moving around, you count 37 occupied seats. Simulate your seating area by applying the seating rules repeatedly until those seats change state. How many seats end up occupied? Ha! Easy. Okay, so let's start with getting the example to the file. For some reason we have an offset. That's strange, but nevertheless. Should we make it one-dimensional or two-dimensional? We can do it one-dimensional, and to learn neighbors we just use width to add to the index, and so we will get the down, or subtracting the width, and we will get. Okay, so at least we need to know width. So it would be lines, unlines rather. No, lines. Okay, never mind. Let's create an array. Array here is pretty natural, so I'm not feel guilty of adding more complexity of array. And array has list array, right? I and the list. No, that's not what I want. I want to have array from. Why do they require the begin index and end index? Yeah, doesn't matter. We just use list array using the length of the list. So for each line, okay, so let's actually define our from list, right? Because array doesn't have from list. Yes, so, and I think it's pretty amazing function which takes just array and returns. Oh, I see. So the problem, so we are using ints, but we also can use something else. So that's why there is no such function. But nevertheless, 0 length excess list array and excess itself, and yeah, for each element from list, and then we will use from list on the arrays. This way we have an array of rows. Yeah. What else we probably want to do is, okay, I was thinking of creating data type for either floor, seat or empty, but I think using characters is good enough. So we have array of character. Oh wait, why don't we use list array and tuples as indices? I actually forgot about this feature. So what we need to do here is say we have lines, not just like seat lines, or rather rows. Okay, so why do we need this? Is to get a width of the first, and then we'll be able. Oh, by the way, we should filter. Filter doesn't equal empty array, empty string. Yeah, good. So what we will do now is we will have length of seat rows, and we have the length of the first row, and it will be height and width, and we use list array to, yeah, we are using list array to create an array. Seat array. So we use list array, and here we say it's from 0 to 0 or 1 to 1. I don't think it would matter. Let's just say 1 to 1, just to simplify the upper bounds. And upper bounds are, so number of rows should be the first, and then should be number of column. So number of rows is length of seed rows, and the number of columns is length of head of seed rows. Let's actually define separate variables for this. We have width, which is seed rows, length, head seed rows, and we have height, which is the length of seed rows. And define this, we will have here only height, width. Okay. We have this, and we use seed rows. Okay. So now we just need a function step. Taking our array, int char, and return is the same. Let's give an alias seeds. Seeds to seeds. Okay, what else do we need? Yeah, we need to know whether something was modified. And simple, we can just compare arrays, right? Yeah, I believe we can do this. So let's check. So array. Do we have array here? Actually, we don't have. Interesting. So array is not comparable. Okay. EQ. Yeah, EQ. It's fine at all. And then just number. Yeah, interesting. Do we have filter? No. So you probably need to go to list and then filter, which is fine. Here. Okay, what else can we do here? Yeah, I believe that's all we need. Let's just write the final function then. So we can use group by. and we will just need a first group with uh, two elements. Yeah, we can use this, but can we use something else to compare to previous, right? So yeah, it sounds like group should work here, because take while, drop while, and so on, they work only on one element. So but yeah, the problem is that lengths should be computed uh, to compare it with 0. We cannot say, oh, it's more than 0, so we don't need to compute the whole group. We actually need to compute all elements of the group, and the last group here will be infinite, because we will have the same array repeating infinitely. So we need to do something else. What we can do is to just combine two arrays. So what we have seeds states, and it will have it will be an infinite list of iterate step seeds array. Why do we define different variable? So we can zip, and yeah, seeds states, but also we will zip in with tail seeds states, and we zip it with not equal, because what we want here is to get the array itself. Or at least we need array plus the result. So okay, I don't think zip is a cool function here to use. I think zip with. I think what we'll do here is drop while or take while. No, drop while equal, but because we are applying equal on tuple, we should use uncarry. Yeah, so the first here would be, and we definitely here have either infinite or finite list, finite node empty list. So head will work just fine, and head, and then we just pick any of them first and print it. No, not print. Okay, so what we need to do is to find the number of occupied seats, which is we'll need to convert to list. We need to filter by equaling to hash and print the result. Yeah, now it sounds nice. Okay, it's compilable. Add to list. There is no add to list. What does it have? Array? Elements? Ah, right, elements. Okay. Elements is just fine. Oh, types. Let's start with the last one, 14. Seed states, iterate, step, seeds state, seeds array. That's not possible. Called filter is applied. No. Couldn't match type T0 with char. Wait, T0A0. 80 seats row. Oh, wait. Seat row. Oh, lines. Oh, I see. Yeah, we need to add the dot here and should be fine. Oh, expected type seats got the actual array of characters. Cool. Why this is happening is seat rows. Okay, so seat rows actually is oh right, because we have list of lists here, and we need just a list of characters, so we are doing concat here. Yeah. Seems good. So now we just need to define step function. So step function is here, is just a window sliding on all cells, and it would be cool. Wait, okay. So the difficult part here is to have a window over edges. So we kinda need default or something to not get out of array. I guess the best solution is just to have some function like default index, which will return 0 if it's outside of an array. So let's actually do it. So with default, find with default, and we have seats, we have the index, and we have default. Yeah, default will be okay. Default will be character, and default will be floor, just because floor doesn't affect anything. Oh, in bounds, right? We have function in bounds, which is quite nice, which we can do here, and we say in bounds, right? In range, yeah, in range. Yeah, in range. In range bounds array ix, and if it's in range, we just return array ix index. Otherwise, we say return default. Let's see whether this works. Parse error, 23 parse error. Alright, undefined. Couldn't match. Find with default has 3 arguments, but its type has only 2. How so? Ah, yeah, because we need to return chart. Yeah, now it's working. Step seat. Okay. So now we should have function to create neighbor indexes. X's let's say just neighbors. Yeah, and we will have a list of neighbors. Okay, so yeah, we want just iteration, and with Haskell it's easy to do. X, Y. I guess it's Y, X. Because first is the number of the row, and we'll have here Y plus dy, X plus dx, where X is from -1 to 1 and Y is from -1 to 1, and X is not equal Y. Yeah, simple as that. So this is neighbors. So what we want to have is all neighbors, fun with default, and the number of occupied seats. And if it's no occupied seats, interesting. I see why the configuration this cell automata is stable, because in the game of life you have rules. The new cell will appear if it's 2 or 3 surrounding living cells, but here it will appear only if no occupied seats are around, meaning it less likely to appear, so it's less like life and more stable configuration. Okay, so what we are saying? Right, so for each seat, and by seat here I mean index. So what we need to have indices. Let's see, have we just indices? Oh, indices, nice. A indices, seats, and for each of them we have to find neighbors, and for each of the neighbor we need to find with default. Yes, find with default we need character, which will be occupied, and we need oh right, so here we will change places with coordinates, because here we are changing coordinates and seats are constants. Seats, yes, we will have the list of characters, and we just filter by equal to occupied, which occupied is hash. Oh yeah, so default is not, the default is floor. So after the filter we just say length, and we will take the number of seeds. Okay, that's quite interesting. So okay, so now we need to change the seed. Seed step. So seed step we will need seed itself. Okay, so it's not as trivial. We cannot write it as one big composite function because we need an original placement, because if nothing changes we need to return original placement. Okay. Seed step, and here we have index of the seed. And yeah, we still need to use this function to determine what we are going to do. Yeah, where num occupied. Okay, num occupied. Neighbors ix, but also yeah, neighbors ix map fine with default. Yes, seems good. Number occupied. Yeah, so what we are doing here is saying num occupied is 0. So if it's 0, then we return occupied. Yes. If it's not floor, yeah, so it's num occupied. Yeah, okay, let's say the seat is itself. Here will be seat. Seats and the index of the seat. So what we're saying is if seat is is not a floor, then number of occupied and number of occupied at 0, then it becomes occupied. Let's start the music. What should we choose? Electronic, lofi, hip hop beats. Maybe. Okay, yeah, that makes sense. What else? So if it's floor, it's always floor. So we can just say that if seat is floor, then we return floor. Then we don't need to do this, because we know here that seat is not floor. If number occupied is greater than 4 or equal to 4, so by our rules it's 4 or more, yeah, it becomes empty, and empty seat is L. Occupied, yeah. And if nothing of previous, then it becomes, it stays the same seat. Yeah, I think we got this. Yeah, we need somehow to use it here. Seat step, right? So in this can we use map with array, right? Fmap, I guess. Array is functor, right? Yeah, array is a functor, so we can use fmap on it. So basically we use fmap on it. But we also want to have indices. Oh, okay. Can we have fmap with indices? That's interesting question. Assocs and range elements index xmap. Oh, xmap. That's exactly, no, it's not mapping of indexes that we need. What is range? Okay. Oh, I see. Index. No. I guess Atom array. Yeah, actually, Atom may be something that we need to look at. Accumulate, because it has accumulator and it will accumulate the array. How does it work? Because, oh, I see. So we have initial value and each consecutive value will be recorded in the array. It's sort of like a fold. It's sort of like scanr or scanl. Yeah, so because we need to have indices, we cannot use fmap. Do we need indices? Yes, because we need somehow to get neighbors. Do we need elements? Not necessarily. Yeah, so having map of seed step will result in the next steps, but you see indices are not really preserved, so we will have just a list of seeds. Yeah, so what we can do is to create a new array, right? Because of that. Not ideal at all. What can we do then? We can just use lists, of course, and actually that's no. Why lists are not perfect is because we want to random access, or at least like ends elements back, which why lists are not great with that. Is there something better than recreating an array? I don't think so. So we probably want to have a socks. I think a socks will be more appropriate here, in the sense that we can just have index and step, and we just a seed. Yeah, just less of what of getting computations, less of code, and we will turn like just new seed, right? This way we can socks. Yeah, so this way we can then say array, and we can use the bounds of the previous array. Seed step, map, seed step, array, and we use bounds of the seeds. Does it work? Yeah, this is multi-var setup. Non-occupied. Yeah, so what we need to do is something like that, probably. Nope. Whoa. Ah, right here. And dx dy. Okay. Sounds good. Wait. Types. Okay. Couldn't much expect the type array with actual type int. 35. What? Ah, right, because I changed, so I need to change the order of arguments too. Okay. Couldn't expect type character with actual in the argument, namely what? Map 28. Find with default character. Ah, right. Because we need to do this. Yes. Okay. Main example. We return empty array. What? Wait. For some reason I deleted length 0, which is not correct. Wait. We have example in, right? Yeah, seems like it. Example in. Why do we have empty array? Let's print height and width, and also print the array itself. Okay, 10 by 10. Okay, array looking good. So something with a step function. But how can it be? So we are getting a socks. We are doing map, and then array again. How can we get empty array? Okay, so let's say take 10 of seeds states and just print each of them. Map m print yes, super useful, super useful. Weight 0. So states are actually proper arrays. They each has 100 elements. But result is 0. Oh right, result is 0 because it's not an empty array. It's that there are no occupied seats. Let us read what I don't know. So let's also say that we have visualization for seats. Two instance show seats where show array would be just to list a socks. Yeah, a socks. Also we will use group by, and we group them by first. Yeah, group by is quite a nice function. Group by first, and then for each of them we just say concat, or no, it's already concat. Okay, it's a socks. So it has also iteration. So what we want to do is to say map second, because after grouping by we don't need index anymore. But it's not just map second, right? It's map second, because we have list of lists. Now we have list of list, but just characters. A list of list, so list of strings, and that's something we need to do is unlines. Illegal, right. There is not a synonym, so should honestly doesn't matter. Show seats. Okay, so we just don't need to print them, we just need to map m, take 10 of seats states. Actually we just need 5 or even less. Show seats, take 5, put strlen. Yeah, take 5 seat states. Or right now I don't understand. Here, okay. Group by first, a socks. Right. Okay, a socks. Then group by first. Then map second. Honestly, I don't understand what's wrong. Couldn't much type int with int character to bool in the first argument of group by, namely first. Expected type int char. Oh right, because we not grouping by the indices, we are grouping by the a row number, which is the first of the first. Let's see. In the second number, namely first. So expected type int in character, bool int. What does it mean? Group by. Right, because group by takes two, so we need. Yeah, right. I forgot about this. List import because group by takes two arguments, so it's not just first, it's equal on first. Yeah, that makes sense. Main example, cool. Okay, and let's compare with the example given in the problem. Occupied. All are occupied. Interesting. So the second step is different. In the example, only on the edges seats were staying occupied, but here for some reason we have diagonal, which is quite interesting pattern. Yeah, some on the edges, but okay. Let's see the rule again. So let's take first element. It stayed occupied, which is makes sense. Let's say first row, third column. It didn't stay occupied. Why? Because was too many, and that's okay. So let's talk about the top right element. Why it become unoccupied? Because outside of it we have only 3. Yeah, that's right. We have only 3 occupied spaces. So seat isn't floor. Number occupied, no, it's not. So also this is not true. Sorry, that should have returned seat, but for some reason it's not. Okay, let's try one thing which I might forgot is -1 1. Okay, that's all right. First is the x not equal to dy, and that's all. Actually, that's all. It's still 0. Okay, but at least now we have a proper seconds. Not really. So again, looking on the we are looking here on the element third column, first row, and this element should have been empty, right? Because it had 4 occupied neighbors, but it's still occupied. Okay, so num occupied neighbors. That's interesting. Filter equal hash should be fine. Fine with default length. Yeah, all of this should be fine. So what's happening here? Seed step. Let's say seed step ix seed. So yeah, for this function to work, we need actually let's just pass num occupied. Yeah, of course we wait. Yeah, let's just make our debugging easier by defining separate function for sets step, seed step, which will take let's say seed int and character, and also it takes seeds and it will return int character. Yes, seeds, yeah, and we have no problems with indentation, which is also, and let's say number occupied is also the similar function which seeds neighbors ix. Which will have seeds, which will have ix. Actually, ix we can neighbors ix. Yes. So we can yes, and it will return us int number of occupied. Quite simple. ix, we can even skip ix, but let's just write it. It's hard enough to write explicitly variable names. Okay, so it doesn't compile. Couldn't match type int with int. What? In neighbors, namely x. Neighbors int. Oh right, because it's not just a x, it's also a seed here. Yeah, my mistake. Also here seeds. Wait. ix seed. Otherwise ix seed num occupied. Yeah, because we need here seed step. Oh. Okay, I've got paged.